Hello, and welcome to a little video I made to help my students on completing the square. This correlates to lesson 3.03 to 3.04. Make sure y'all complete each part of the lesson in my course, including the practice and the quiz, which is for a grade. The learning targets are, we need to be able to complete the square to create perfect square trinomials. So this is just another method for solving quadratic equations. Solve perfect square equations. This connects to our standard AREI B4, A and B4B. Completing the square is a method. Use the method of completing the square. And this is going to dip into our taking the square roots from yesterday's lesson. Because after we complete the square, then we solve by taking square roots. We're going to need to know these factoring patterns for perfect square trinomials and how to solve equations by taking square roots, bridging us into completing the square. So it's important for us to be able to recognize standard form and the coefficients. So just want to recap here. The square term is our quadratic term. And the A, the coefficient, this is called the leading coefficient, the number that's in front of our x squared. And then our second term is called the linear term. And the letter in front of it is the linear coefficient, because it's part of the linear term. Not the variable, just the number. And then the last term is the constant term, the one that does not have a variable on it. Okay, no variable, just the number. So when I refer to A, B, and C, that's where that's coming from. So I want to recap perfect square trinomials. So to find these products, a special pattern happens here. I'm actually going to use the pattern because that's what we're looking for here. A perfect square trinomial, you square the first number, you square the last number, and then the number in the middle, the term in the middle, is going to be 2 times the x and 2 times the 3. So we end up with 2 times x times 3. So in the middle we end up with 6x. This pattern, we're going to be going backwards. We're going to be starting with the perfect square, already done, and working backwards to figure out the perfect square. So we square root the last term, square root the 9 to get 3, and we divide that middle term by 2. So I'm going to move this up here. 6 divided by 2 is 3. 6 divided by 2 is 3. 3 squared is 9. And I use this kind of check mark process to figure it out. Divide by 2 and then square it to get the last term. So on this one, it would end up being x squared minus 10x plus 25. Again, divide by 2 to give me negative 5, and then square it to get 25. I can make a check mark. I divide by 2, and then square to get the 25. That's the pattern we're going to be using to convert these perfect square trinomials back into their factors. So here's some examples of fill in the blank. The completing the square method is the process of transforming an expression in the form x squared plus bx. I'm going to zoom in on that. In the form of x squared, so we have our quadratic term, and we need our linear term. QT for quadratic, LT for linear. So we need these two parts in order to complete the square, the quadratic term and the linear term. And we're going to make it a perfect square trinomial by adding the c term to it. So we're trying to find that missing number. So in order to do that, going back to our pattern, to find our C, we're going to take our middle term, divide by 2, and then square it. So this is going to be x plus 5, and then we square the 5 to get 25. Again, check mark. Divide by 2, square it. Divide by 2 and square it. Here, negative 14. Divide by 2. Negative 14 divided by 2 gives us negative 7. And then we square the negative 7 to get 49. Number 3. So this one right here, this is where our formula is going to come from. We're going to use this example to develop a formula. To complete the square, to find the number that goes in a blank, it's x squared, so this will just be x. We take our middle term, our linear term, divide by 2. So this is b divided by 2. And then we square that. So since it's just a b and a 2, we're going to write this as b divided by 2 squared. So our formula to complete the square, C, your new constant, the missing constant, is going to be that linear coefficient divided by 2 and then squared. That is our formula. Divide that linear coefficient by 2 and then square it. Let's write that out. Divide the linear coefficient by 2, then square it to find the new constant. So we're going to apply this process to some quadratic equations so that we can solve them by square roots. So here's some more examples on how to find the constant. Take a moment, pause the video, and try to do it on your own. Okay, so I'm hoping you took the time to try to find the constants on your own, and I'm going to tell you what they are. Divide by 2, I get 9, and then square it, I get 81. Divide by 2, square, 81. Number 2. Divide by 2, that's just going to be 9/2. Don't sweat it, leave it as a fraction. Square it. We're going to get 9 divided by 2 squared, and before you freak out, just square the 9, that's 81. Square the 2, that's 4. So the constant for this one would be 81 over 4. Again, follow the check mark. Divide by 2 and square it. Number 3. This is a negative 1. So it's going to be divide by 2. So that's just going to be negative 1/2. Don't freak out. Let's leave it as a fraction. And then square it. C equals 1/2 squared, so that's going to be 1/4. Our new constant is 1/4. And then number 4 here, you might have been freaked out by the fraction, but we're going to figure it out together. All right, why? When I divide by 2 with this fraction, that's the same thing as multiplying by 1/2. So this actually ends up being 2/10. And then when we square it, we can actually simplify that. Let's go ahead and simplify it. y plus 1/5, and then square the 1/5 to give us 1/25. So the new constant for number 4 is 1/25. A little bit more involved with that one. But as long as we remember that multiplying by 1/2 is the same as dividing by 2, it's no problem at all. So that's practicing finding the missing constant. We haven't started solving it. So solve by completing the square. I'm going to write the steps as I go. First things first is the quadratic term and linear term must be on the same side. So if we look here, we have our quadratic term, 2x squared on the left side, but then we have our linear term, negative 20x on the right side. And we can fix this by adding the 20x. I'm going to move it, I'm going to cancel it out from the right and move it to the left. So this will become 0. And on the left side, I'm just going to squeeze my 20x right here in between. 2x squared plus 20x minus 48 equals 0. So this is a must. We have to have our quadratic term and our linear term on the same side. The next thing that we need to look at is we need to move the old constant to the opposite side. We don't want it over here. We're about to get rid of it. And I'm going to use QT and LT for quadratic term and linear term. Okay, so I got my quadratic term and my linear term on the left side, and I move the old constant to the opposite side. So I can do that by just adding 48. Just get out of here. There's no room for you on this side. So I have 2x squared plus 20x. I'm going to leave a little blank, okay? My blank is for my new constant. And I remember, whenever I add to one side, I have to add to the other. So I'm also going to put my blank on the right side. I got to keep it balanced. So that was my step 3. Include blanks on both sides for the new constant. And actually, before I even get further than that, I noticed that my leading coefficient is 2. This is a problem. Okay, I can only complete the square if a equals 1. Okay, so if a does not equal 1, divide everything by a. So that will look like this. I'm just going to divide everything by 2, ignoring my blanks for now because there's nothing in there. X squared plus 10x, bring down my blank, equals, that was 48, wasn't it? 48 divided by 2. So that'll be 24, and I still got my blanks. Now, we find the missing constant. Use negative b, or b divided by 2 squared to find your new c. the new constant. So here we go. X divided by 2. 10 divided by 2 is 5, and then 5 squared is 25. And what I add to one side, I have to add to the other. Divide by 2, square it to get 25. And what I add to one side, I add to the other. I get x plus 5 squared equals, I can add these two together, and I'll get 49. I'm almost done. I'm going to shrink this up. So now that I have my new constant, I can solve by square root. Solve by square root. So I take the square root of both sides. That cancels out my square, and I just have x plus 5 equals, don't forget plus or minus, 7. And now it's just like what we did yesterday. I can write two equations and solve it. X plus 5 equals 7, and x plus 5 equals negative 7. Subtract 5, x equals 2. Subtract 5, x equals negative 12. So our two solutions are 2 and negative 12. So pause this video and read through the steps one more time before I move on. While I readjust. And then we have more examples. I'm going to do one where we don't have to divide by the leading coefficient, this one right here. So I notice how I already have x squared and x on the same side. So I get to skip those first couple of steps. I'm going to throw in my blank to make room for my new constant. What I add to one side, I have to add to the other. Divide by 2, square it, add it to both sides. 15 plus 49 is going to be 64. And now we can square root. And I get x plus 7 equals, don't forget the plus or minus, 8. I can write my two problems, one with the positive 8, the other with the negative 8. And solve. Subtract 7, x is 1. Subtract 7, x is 15, negative 15. And then we just have some more examples, but I highly suggest you complete the examples in the course. Don't forget to take your quiz and email me if you have any questions.